purpose of this video is to explain my final year project. My final year project was to enable a developer to build an Android application by writing Python code to implement it. The reason why I decided to do this project was because at the moment there isn't too many options for writing code for the Android platform outside of using the standard Java framework, and there are a number of reasons why a developer might want to use Python for their application. There is the pragmatic ones, like a company may have a number of existing Python developers working on their back end, and they might want to use the same developers to work on their front end application. And then there's also the fact that one of the strongest correlations between defects in a software project is the size of the code base, regardless of which language it's developed in. And Python enables the developer to write quite clean, concise code compared to a lot of the verbosity required for implementing anything in Java. And this conciseness of the code reduces the chances for a developer to introduce defects into their application. So there is one current attempt to get Android applications written in Python, which is the Kivy library. Now this works by creating an OpenGL surface and rendering its own custom UI widgets with their own entirely new behavior and everything into this OpenGL surface, so they don't behave the same as the native UI elements, and the apps don't integrate as well with other parts of the system as an application written using the SDK directly would. This isn't inherent to writing an application in Python, however, so my project was to enable a developer to write a more native working Android application through Python. There's two components I built to achieve this, and a number of smaller parts. The two major components is a library that the developer will use from their Python code to call UI widgets, and this internally will communicate with the other half of the library written in Java to actually implement, to call the SDK and implement what they need. So the developer just imports a normal Python library and accesses it. The second part is a number of build tools, which are used to take all the developer's code and resources and everything needed to actually get Python running on Android, bundle it into a normal APK that they can then do whatever they might want to do with it. They can install it to the device, they could sign it and upload it to the Play Store, they can do whatever they need to do with the application. From that point on, it's the same as any other application. So as far as the library goes, there's a number of features of it. The first and most obvious one is that it enables access to standard UI components. Buttons, which are the normal buttons, action bars, which are the normal action bars, and they will all behave as well as the end user of the developer's application will expect them to. The second one is that it integrates neatly with the Android platform itself. The developer can create separate activities and with correct lifecycle for if the application is navigated away, for example, to deal with a notification. Features that the user might expect to work, like the back button and switching between apps with the app switcher, all work correctly. Another major area is integration with third-party applications, so you can launch other applications from yours. For example, in the sample application, which I will show in a minute, the developer can launch the email application to send an email. Another important thing is that many teams, they will often have someone else handle the UI design compared to the developer, and they might wish to continue using their standard tools that they were using before to create a layout. So as you can see on screen, for example, they might want to use the UI editor from Android Studio, and anything that creates a standard XML file can be used. So the developer, the UI designer for this application does not need to be aware of the fact that the developer is using the Python library. So you can see here, this is just a standard XML file that could be generated by Android Studio or any other tool that the user might want to use, and that's loaded to create the layout on the device, which you'll see in a moment. As far as testing goes, I have implemented mocks of parts of the framework so that these tests, the developer can write unit tests for their application that can run independently of an Android device. The reason for this is largely because the developer might want to have quick feedback on their tests, and if they need to build an APK, connect it to a device, send it across, install it, and launch it, and it can be very slow, especially if they're using the emulator, because the emulator is very slow compared to a real device. For example, the emulator, even just using a normal app written using the Android SDK, it can often take 5 minutes to launch the emulator and another 2 minutes to launch the app to display one button. So if you can avoid the need to actually do that for testing, you save a lot of hassle. For full-on integration tests, because the app is just using the standard UI framework, creating widgets as normal, you can use tools that like UI Automator or the Selenium backend for Android, which is called Appium. You can use any of these tools to test your UI, and many of these, because these are running on your local computer, have Python support already. The build system is done using Gradle. It's implemented as a Gradle plugin. The reason for this is because the Android build tools can be reused that way. The current versions are written using Gradle, and this enables the developer to have a single place to configure everything related to their application builds. They can configure the Android application build tools. For example, if they need to point them to a signing key, they can configure the library that we're using. So for example, here is a build script. The first half of it is just loading the PyDroid and Android plugins to create the application. And then, as you can see, the actual app specific configuration is quite small. In this example, there's only 4 parts to it. So this is quite simple for the developer, and even what's needed to get an application is quite simple. Here is the root directory of the application. You can see it has, a couple of source files and a couple of Android XML files for layouts, etc. Even the code that the developer might write can be quite simple. You can see here, for example, it's all relatively simple code to set up this UI, and they don't need to worry about as many details, such as having to deal with anonymous action listeners in Android for handling events. So you can see here, you can just give it a callback on this line, and just throughout the framework there's a load of small nice developer experience things like that to make it much simpler for them to write their application. After this, I will show the demo of the Android application running on an actual device that's built with this example, but just before I get to that, I'll show the build process. Now, I've already run this. I ran a completely clean build, and then I ran an updated build to demonstrate the amount of time it takes. So you can see the first time, just from nothing, you're just building a new application for the first time, it took 6.5 minutes. Most of this is one-time setup that the developer will not need to repeat, such as cross-compiling Python for an Android device. So the second time, when you merely change source files or your application itself, you can see here it took 15 seconds. Now, I'm running this on quite a powerful computer, so on slower devices you're looking at 10 minutes for the first build and about 30 seconds for subsequent builds once you change your source code but you're not changing the version of the PyDroid library that's in use. So now if I go to the demo, and I will talk about the application implemented for the demo. Thank you. As you can see here, the sample application is running on a device and performance is reasonably responsive. You can go into a new activity, you can view all the standard UI elements. The back button works as all the standard UI features do, and another important feature is that it can integrate with third-party applications. As you can see here, it has launched the email application. So you can see the sample application highlights many of the features that are now available to implement from Python code that previously required Java code.